process unit. First, second, and third year students will be going through this with different um, requirements, but this presentation will fit all of those. Okay, so day one, the essential question is what is engineering and how do engineers solve problems? So this is the lesson plan for this day. We're going to look at the engineering design process. Um, we're going to talk about what is engineering, how do they solve problems. We're going to review the program capabilities we looked at, and I'll go through that in a second, and introduce the unit and introduce logbooks, and you'll consider getting a teammate. So, first thing, take the pretest. This is in your Unit 2 Engineering Design Process folder. Take the pretest. You'll get 50 points just for taking that. Doesn't matter what you score, it is a formative assignment. Second thing, I want you to look at these videos. First years really focus on the first one. Second and third years look at the next two, but it would be wise for everybody to look at all three of them. They only enhance and help you understand. This is a definition you can read. It's adapted from Teach Engineering, and it defines the engineering design process. So we look at several different ones to make it clear to you. And again, if you're listening to this, you weren't at school, so we're doing an abbreviated version, but we want you to understand that there are multiple forms of the engineering design process. This is the IB design model. This is similar to the one we use. This is more for elementary, but they all do the same thing. You define the problem, you understand what the problem is, you come up with a possible solution, you create that solution, and you test and evaluate that solution, and they all are iterative. They go in a circular manner, but they can skip steps, and you go through until you get the process completed. All right, here's another video that explains the engineering design cycle. That is the cycle that engineers use to solve problems. No two problems in engineering is going to be the same. So the focus is on a process that allows you to process information in a manner that we get consistent results and a proven method. And again, there's several different ones, but they all pretty much do the same thing. Here is the design process that we use. It is cyclical, problem definition, research and investigate the problem, develop possible solutions, choose the best solution. Then there's some developmental work before you actually build a prototype. Then you build a prototype, test and evaluate, and then ultimately you present. But you will go through this several times, sometimes back to the beginning, sometimes just back 2 or 3 steps, but it is looping back and forth in an iterative manner. All right, another essential question that we looked at in this lesson is what tools do engineers use to help organize their ideas? There's a handout that you should read and become familiar with on the engineering logbook. The rules on it should be a bound book. It should be numbered, even if you have to write the numbers in yourself. Everything should be in ink, and basically all of your ideas, whether it's sketches, whether you talk to somebody, whether it's calculations or whatever, pictures that you cut out and put in there, that's where you keep your ideas. It can serve as a legal book if there's a dispute over intellectual property. So we want to keep that according to that document that I gave you. So pay attention to that. And everyone should get a engineering logbook ASAP. Okay, the other thing I want you to do is to think about your team members. We will be doing teams, first, second, and third year students will be doing teams. There will be a team of 2. Research will be teams of 4. They're using a slightly different method. They will be using design thinking, which was developed. We're using a course from Stanford's Design Lab, and we're going through that now. But they'll apply that when they on their project. Okay. So what we did this first day was just get an idea of the kinds of things we can make in the lab. We have the capability to laser engrave, as you see there. We can engrave in wood. We can form things with the vacuum former. We can create signs like you see here. Even the LED, we have electronic capabilities, and we actually have some of the LED ribbon lights to do that. We will be doing dye sublimation. We are getting a new dye sublimation printer and a heat press, and here is some examples of that. So what I would encourage you to do is to just use these terms to look at the internet, and we just introduced it this day. You will do more with that as we move to the next day, but this is day 1. Obviously, I spent more time in class, but I'm giving you the overview. Day 2, and again, just like on the first unit of safety, this is the day that you would take it. So depending on whether you're A day or B day, here is what you will see. So we introduced the Spirit Design Project. If you look in your folder, you will find a design brief that goes in detail. It is 4 pages. It gives you the problem, the context, the constraints, all of that. And I'll go over that in more detail in a second, but this is what we're doing this day. Day 2, we review the design brief. You're going to select partners and sign up, and you're going to brainstorm. And here's what you have to submit and a point value. All right, so let's dive right into it. So the first thing we did was look at the brief. There are like 7 parts. The context of the problem, and you should read this. A copy of this is in your Schoology folder for Unit 2. Here is the purpose and the focus. Here's the objectives. The problem is described. Rules for the challenges are given, and the design constraints are given, as well as the schedule with all of the deliverables that you'll have to do as part of this process. Okay, so at this point, teams are selected. Those who are here will select. If you reach out to somebody who is here, they can put your name down and I will honor that. If you do not get selected and sign up, then I will form a team of 2 people. So it's better if you do this. But for first, second, and third years, there's going to be groups of 2. Fourth year research class will be groups of 4. So I have a team contract, and you should have that in your folder, and you will sign that and turn it in, and then we will get you on a team, basically which ones you signed up. Now on that sign up, you get their name and their contact. You write down when you guys are going to meet and what platform you're going to meet on. You need to plan for at least 1 hour outside of class that y'all may get on Zoom. You may use whatever method you want to. But really think about your partner. We're going to be doing more and more projects because teamwork is really a key soft skill we want you to learn. But you really need to think about your partner. In this case, I'm letting you choose that. Sometimes you won't have that opportunity. Establish where the group info is held. This is really key. Oftentimes, one person will hold all of the information, and then that person may get sick or may leave school and go to another school, and then the group members are like, well, we can't do anything because they have all of our stuff. That's not an excuse. If you are working with a partner, then you should have that in a Google Drive that everybody has access to. Everybody has the right to edit and change. and download, and I would even keep a copy in my folder too if I had to download it. But that was the team selection. All right. Now, today what they did was they just got ideas, right? Like the graph I showed you. Let me pull it up here. You looked at as many products and as varied products using these search terms that we can produce in-house, because that's the rule. As you look through that brief I gave you, we have to be able to do this in-house. Now, you don't have to do everything. For instance, you might buy these blanks. You don't have to. We can cut these on the laser cutter from a large sheet, but it may be more cost effective to buy them and just add the dye sublimation ink on the back. But it has to be something we can do. That's number one. It has to be profitable. That's number two. We're looking, when you consider the in the design brief, it goes into detail. When you consider the cost for the material, all the material, and I'll show you on this one, the labor is involved, and amortize the equipment that's involved, we should be able to then sell the part for 3 times that. So you got to give some thought to it, but get a variety of products. Don't get all this like the cut acrylic. Don't get all like barn wood and things like this, but get a variety of things. So you may have a variety of dye sublimation products. These kind of awards things, earrings may be of same technology but different, but try to get some differences there. Okay, let's go back to this. So here is, after you have gotten 3 or 4 ideas, you're going to narrow down to one. And these are the areas I want you to do some thought in and get as much information as you can. It may be right, it may be a little off, but I want you to think through this. So talk about the material. If you said, hey, this is what I think we ought to do, then talk about what material is needed. Here you need acrylic. It looks to me like that's 12 by 12. It's a 1/4 inch thick. I'm going to need this edge light attachment here so it shines up and kind of glows, and the suction cups and hooks, or a stand. I could take this and design it where it sits on the stand and be like a nightstand. The equipment that I'm going to use is pretty much just the laser cutter, so that would be the only thing I'd have to look at cost for that. The labor, it's going to be cost labor to actually put this in and cut it and get it all prepped and ready to go, and then to assemble it. Now, when I look at potential markets, and all of this is spelled out in that design brief, students might want something like this, parents could possibly want this, and alumni could possibly. So it meets 3 of the 4 markets that we were going after. And just as I looked around and saw what signs like this cost, it seemed like $24 to $30 it would be a good price range. When I did some research on cast acrylic, which is what we would have to use to laser cut, and the little LED things, that was $4 to $12 itself, but I think I could get all the material for $12. Now, the goal is to get 3-time return on the investment. I don't think, with the numbers I see here now, is 2 to 2.5 times return on investment. And then the last thing here is the pros and cons. The pros are in green, the cons are in red. So here it's relatively easy to make. The product is very flexible. It could be Blue Devil football, baseball. It could also be, if we reach out to the middle school and we're making that for them, or for MCAA or Hickory Hills, it could also be those. The downside is the LED frame parts are very expensive. Now, we may come up with another way with just the strip LEDs that would be cheaper, but that's for a later date. But this is just a sample. So you were to find one, narrow down to one, and answer these questions as best you can, and then you're going to submit this. And we are going to do a gallery walk with that, but that'll be in the next class. Okay, here is day 3. So in this day, we're going to do the gallery walk of the products, that little template that you guys created. We're going to do that, and as a class, you'll have three sticky notes, and we will select the top three, and they need to be um, and they won't all be the same kind of products. Okay, so we'll kind of group them together. Um, so in this day, we're going to talk about problem definition and constraints, right? So your deliverables is going to be to do a refined problem definition based on the problem I gave you in the brief and the new problem that the product that we're looking at selecting. That'll make more sense when we go through it and as you go through the material. And then here is refine the design constraints. So as we go through it, we're going to do the gallery walk. Everybody gets 3 votes. You got to tell me what to vote. You got to tell me one thing you would improve or do differently or add to it. And then the top 3 designs are chosen, but we want varied types. So if we got 2 that are similar, we'll kind of group those together and you will vote on that. And then your team will choose which of the 3 products that we've looked at and decided on your team wants to do. Okay, when we talk about problem definition, we are trying to define the problem. So it's all about listening, having the information revealed so that we understand what the problem is. All right, so here is when we talk about a problem statement, a well-defined problem statement adequately defines the problem, but not the solution. We're not trying to say, here's what we ought to do. We're just saying, what's the problem? And it establishes an agreement between client and engineer. So for our product, we're saying there's a need for school spirit homeware, say for instance, that also serves as a nightlight. Now we're kind of working a little backwards because we do have the product, but then we're going to look at that. But here we're just trying to say what is the problem. If it's poorly defined, it's ambiguous. You don't know what to do because you come up with it doesn't really, it has so much, it's so unclear, you can't focus on what needs to be fixed. But developing a well-defined problem statement is the first part of defining the problem. All right. For one of the things we do is use the who, what, when, where, why, and how. This is Einstein. He said if he had an hour to solve a problem, he would spend 55 minutes thinking about the problem and 5 minutes about the solution. First, that seems backwards, but that makes a lot of sense because if you understand the problem, the solution will come. But the biggest thing is not understanding the problem. So we use the who. Who has the problem? Are they young? Are they old? Are they large? Are they small? So we talked about 4 markets. Which market has a need for sports paraphernalia? Well, maybe parents, maybe, but primarily students. So who has the problem? That's important because if I'm designing a chair, I need to know that before I can begin to think about designing the chair. What will they do in the chair? We're using this chair as an example. There's a need to, you have to design a chair, but I want to know what are you going to do in the chair, right? You're going to eat, you're going to talk, you're going to relax, you're going to sleep. What are you going to do? And when? When is it used? Is it used every day? Is it used on special occasions? That helps to frame the problem. Is it a problem all the time or just when it's cold? Where is it a problem? Where, if it's a chair that I'm going to design, where is it going to be used? Is it inside? Is it outside? Is it in an automotive shop? Because that's going to change a whole lot understanding that. And then why? Why is this a problem? When you think about a chair, why is the chair being used? Is it being used to be seen? It shows your importance. Is it to establish authority? Is it so I can see? Is it so I can have mobility? Asking these questions to understand the problem really gives you insight on a possible solution. And then how is it used? Is it used to heal? Is it used to harm? How much will it cost? We're just trying to ask these questions, and all of them may not fit, but they will help you to frame the problem to understand it. So here's an example of a bad problem statement. XYZ Corporation needs a new chair designed for a client with disabilities. That's too broad. It doesn't clearly define the problem, and it also defines the solution. It's a chair. Well, maybe that's not what you need. And it leaves so much room for ambiguous solutions that it's just not clear, right? I don't know what kind of disability, I don't know how old the person is, but look at this one, this better. There's a need for a low cost, lightweight, custom orthotic seating device that provides everyday neck support to young children with spinal injuries who lack neck control. Now this is better. I won't say it's the best, but it's better. It clearly defines the problem. It's a child that has had a spinal cord injury and they can't control their neck. It needs to be low cost. It needs to be lightweight. It's going to be customized for that student. So what you are going to do at this point is redefine the problem statement. So individual members will write a redefined problem statement for your team's project incorporating the requirements from the design brief. So now you're writing it with what they said, but now you are incorporating some other information. And this will be iterative, so you may go back and do this again. We don't have a client at this point to talk about, so you just kind of think through it as a student. And that should be written in your logbook, okay? And then you're going to take a picture of that and submit that refined statement. That is a deliverable that you will get points for. All right, second half, and this will be the strategy. I'll talk about it, you'll do it. I'll talk about it, you'll do it. We want to talk about, now that you've got a good problem statement, you want to add qualifiers, right? Constraints, limits. So good design constraints sets limits to the aspect of the problem, just like the baseball field. You know where a foul line is. You know where you've got home, where if the ball goes beyond that, it's a home run. You know where first base, second base, third base, where the pitcher sits, where home plate is. That is constrained, and you have to play within those guidelines. It also establishes clear outcomes. It doesn't constrain the solution, and it can serve as a legal criteria. You're going to use this when you make a prototype to say, did I meet this? So let's look at that. So here is a way to further clarify this good statement. Low cost. Well, what is low cost? Here, it should be under $35, because low cost may mean it's less than $500, right? Or it could be, I'm talking about something under $35, but I've spelled that out so you know. Lightweight, well, I'm putting a number on it, 5 pounds. Custom orthotic device is fitted for a child. And it should be made in such that you can adapt it, but you can use it for about 18 months as that child grows. Everyday use, okay? Be specific. What kinds of everyday things? In a school desk, as a car seat, and more. So the more you can spell out, because you can't make one device that solves all the problems, so you want to narrow down to what you are talking about. When we say young child, instead of putting it in years, because kids differ so with size, we put their small size in a weight or maybe even a height constraint. And then when we said neck support, we spelled out that is to support the head and brace the cervical column from C3 to C7. So again, I'm getting the solution that I'm looking for more and more narrow. All right, you're going to spend time I've given you some constraints. You're going to add to that list and begin to put numbers on it. Cost might be some. Tell me how much are you looking at spending and things like that. Okay, we're going to stop here. I'm going to record this and upload it as my lesson plan. All right, I'll do this part 2 to follow this.